Welcome to the presentation on Domain-Driven Design, DDD. DDD is an approach to software development that focuses on aligning the software design with the domain it represents. This understanding is then used to create a software model that accurately reflects the domain. DDD is a powerful technique for developing software that is both maintainable and extensible. It can help to reduce complexity, improve communication between developers and domain experts, and make it easier to change the software as the domain evolves. In this presentation, we will explore the core concepts, principles, and benefits of domain-driven design. First, we look what is the definition of domain-driven design. Domain-driven design, DDD, is an architectural and design approach that puts the domain at the center of the software development process. It emphasizes understanding the business domain, modeling it effectively, and creating a flexible, maintainable, and scalable software solution. In here, we're talking about key concepts of domain-driven design. First concept is ubiquitous language. Ubiquitous language means shared language and glossary used by domain experts and developers to eliminate communication gaps. It creates a common understanding of the domain model and fosters collaboration. Next, bounded context defines a clear boundary within which a specific model, language, and context apply. Helps manage complex domains by breaking them down into smaller, cohesive contexts. Aggregates clusters of related objects treated as a single unit. They ensure consistency and encapsulate business rules. Entities. Objects with a unique identity that persists over time. They have attributes and behaviors relevant to the domain. Value objects. Objects without an identity, defined solely by their attributes. They represent concepts in the domain and are immutable.
Strategic design patterns. DDD provides strategic design patterns that help shape the architecture and organization of software projects. Some key strategic design patterns include context mapping. Context maps help in understanding the whole project, being able to show the relationships between the different bounded contexts. It is extremely important to understand the relationship between bounded contexts so that you can build a domain model correctly. Shared kernel. A shared context between two or more teams, which reduces duplication of code. However, any changes must be combined and notified between teams. Customer, supplier. It is a relationship between client, downstream, and server, upstream, where the teams are in continuous integration. Conformist. It is the scenario that involves the upstream and downstream teams, but in this model the upstream team has no motivation to meet the needs of the downstream team. Anti-corruption layer. It is the scenario where the client, downstream, creates an intermediate layer that communicates with the upstream context, to meet its own domain model. Domain event. A domain event is something that happened in the domain that you want other parts of the same domain, in process, to be aware of. The notified parts usually react somehow to the events. Tactical design patterns. In addition to strategic patterns, DDD also offers tactical design patterns to handle the internal structure of the domain model. Some common tactical design patterns include aggregate. It is one of the most important and complex patterns of tactical design. Aggregates are based on two other tactical standards, which are entities and value objects. An aggregate is a cluster of one or more entities, and may also contain value objects. The parent entity of this cluster receives the name of aggregate root. Repository. Repositories are mainly used to deal with storage. They abstract concerns about data storage. They are responsible for persisting aggregates. Factory. Factories are used to provide an abstraction in the construction of an object, and can return an aggregate root, an entity, or an value object. Factories are an alternative for building objects that have complexity in building via the constructor method. Domain service. Services are stateless objects that perform some logic that do not fit with an operation on an entity or value object. They perform domain-specific operations, which can involve multiple domain objects. Value object. Value objects are immutable and do not have a unique identity, are defined only by the values of their attributes. The consequence of this immutability is that in order to update a value object, you must create a new instance to replace the old one. Domain event. Events indicate significant occurrences that have occurred in the domain and need to be reported to other stakeholders belonging to the domain. It is common for aggregates to publish events. Let's see benefits of domain-driven design. First benefit is improved collaboration. DDD fosters collaboration between domain experts and developers through the use of a shared ubiquitous language. It bridges the gap between technical and business stakeholders. Next one is enhanced domain understanding. That means by focusing on the domain, DDD improves the understanding of complex business domains. It helps in capturing and modeling complex business rules and processes effectively. Another one is maintainable and evolvable codebase. DDD's emphasis on bounded contexts, aggregates, and domain-driven architecture leads to a modular and maintainable codebase. It enables easier refactoring, extension, and evolution of the software solution over time. Key takeaways. Let's check what are the key takeaways in this article. Domain-driven design aligns software development with the business domain. It emphasizes a shared ubiquitous language, bounded contexts, and strategic and tactical design patterns. DDD improves collaboration, domain understanding, and maintainability of the codebase.